Hello, and in this video, I am going to walk through what is percent composition and how can you calculate it. So let's get started. So for percent composition, what it really is, it's the mass percent of elements in a compound. But let's just kind of go back to what is percentage. So that's kind of our first question. What is percentage? Think about that for a minute. Hopefully, you would understand or remember from learning somewhere along the way that anything that really is a percent is just talking about really it's fractions. It's talking about the part of something over what the whole thing is. So taking that ratio and then multiplying it by 100%. So that's what percent is of anything. It doesn't have to be elements in a compound. It can be anything at all. Kind of here's an example with boys versus girls. Let's say that we have a class that has, 15 boys and 10 girls in it. What would be the percentage of boys versus girls? Well, we would then know that we have a total of 25 students. So to find our percent of boys, we would just take the part that is boys, so 15 boys over 25 total students. Multiply that by 100. So we would get, pardon me, calculator. So we would get 60%. That would be boys, and percent that is girls. 10 girls over 25 students, or total. Students or total would be fine there on the bottom. Either one is okay, and we would get 40% girls. So, that's just generally what percentage is. And of course, remember, whenever you're doing any type of calculation with percentages, that everything should add up to 100. And of course, we see that here, 60 plus 40 is 100. So that's what percentage is in general. Percent composition for chemistry class is your mass percent of your elements in a compound. We're going to go through 2 examples of how to calculate this. There are actually 2 different types of percent composition problems. So you need to be able to recognize them. The first one here on your slide, let me scroll down to give myself some space, is if you're giving masses, giving lab data. So this is where somebody went into the lab and they took an unknown compound and they split that compound apart into the elements. And they found that when they did that, they had 5.5 grams of hydrogen and 44.5 grams of oxygen within their sample of the compound. And so we could then figure out what is the percent composition of the compound by just using the idea of the part over the whole times 100. So here's how we would do this. We would just say, okay, the percent that is hydrogen is going to be the 5.5 grams. And then we are divided by the mass of the whole compound. So we do need to know the total mass here. So we'll take our 5.5 grams plus our 44.5 grams and realize that the whole mass of our compound, of the sample of our compound that we have, is 50 grams. So we would say 50 grams of the compound. You're going to see me throughout this course use the abbreviation CMPD for compound. You can certainly use that for, rather than writing out the whole word. And then again, multiply by your 100%. So as you stick this in your calculator, you can see that the calculator would spit out to you 11, but we want to make sure we're concerned with our sig figs. You see we're getting 3 sig figs from the top there, and the hydrogen, so it would be 11.0, and you always need to include a unit. You also always need to include a formula on everything. Make sure that you're given number, unit, formula, or number, unit, substance, as some the other chemistry teachers here use, but you need to have all three of those labels on everything that you use. Now, for the oxygen, same thing. It would be 44.5 grams of the oxygen all over the 50 grams of the compound. We can't really give the actual formula compound now because we don't know what it is. That's why we're actually writing the word compound here. We will be able to figure out what it is in a few minutes towards the end of the video. I'll talk about that. And so we get 89.0% oxygen. Again, pay attention to sig figs. Make sure you're paying attention to sig figs. So that is our percent composition of this unknown compound. As far as showing your work, what you see on the screen is exactly what we would like to see. So just make sure that you're doing that. Now, there's a second way to figure out percent composition. We're going to actually use the same two elements here. We're going to figure out this when you're given a chemical formula. So what is the percent composition of water when you have a chemical formula? So for this case, first of all, the first thing you need to remember or know is nomenclature. That if you don't know what the formula of water is, you're going to have a hard time figuring out the percent composition. So hopefully you know water is H2O. But, you know, let's say we gave you another one of, you know, aluminum hyposulfite. Would you be able to give that formula? So this is where, you know, remembering all your nomenclature is going to be important to doing these problems. Okay, so we're going to keep with the water here to determine the molar mass of the compound is the next step. So you should be able to go to your periodic table and pull off each of the masses of the individual elements. So for water to determine its molar mass for hydrogens, we would have 2 times the atomic mass of the periodic table, which is going to be 1.0 grams per mole. For oxygen, it's just going to be 1 times 16.0 grams per mole. And so we get 2.0 grams per mole coming from the hydrogen, and we get 16.0 grams per mole coming from the oxygen. So we have the molar mass of water is 18 grams per mole. So that's kind of step 2 for figuring out the percent composition given a chemical formula. Now this is where you know, you got to think about it a little bit here for the next step. So really all we need is we just need to have some amount of mass of the hydrogen and some amount of mass of the oxygen that also corresponds to the ratio of the mass of the compound. So you could really use any amount of the compound that you want. You could say, oh, well, you know, let's start with 1 gram, let's start with 12 grams or whatever. But the simplest way to do this is to assume that you have 1 mole of the compound. So if we assume that if you have 1 mole, then we know that we are going to start with 18.0 grams of water. So this 18.0 grams is going to be our whole amount. Then we also know, since we understand the molar mass and the relationships, we know that in that 18 grams, 2 grams is going to be the hydrogen and 16 grams is going to be the oxygen. So really what you do here is you just break the, you know, use your numbers from calculating your molar mass, but you're using them almost as grams here. So you do need to show your molar mass calculation, but you also need to show percent composition calculation. So we will do percent hydrogen is going to be equal to 2.0 grams of just hydrogen all over the 18.0 grams of water. Again, remember number unit formula times 100. Again, pay attention to your sig figs. So your calculator gives you 11, and in this case, we only have 2 sig figs coming from the hydrogen on the top, so 11 is appropriate. Be 11%, and again, listing hydrogen there. Always even on your answers, number unit formula. Then do the same thing for oxygen. So now we have 16 grams of that 18 grams is oxygen. And here we would have 3 sig figs. So we have 88.9% oxygen. So, you know, what we can see here is, you know, just doing it from the actual formula of the compound, you know, all you really need is the periodic table to know the masses of the individual elements and calculate your molar mass. Now, you may notice if you look here for the compound, we've gotten 11% hydrogen, 88.9% oxygen. That is very, very close to what we found up here in example number 1. And the reason why we kind of found the same answers twice is that actually the compound that this unknown compound that we had in example number 1 is actually water. In that what chemists actually do in the lab is that they go ahead and they find percent composition, and then from the lab data, and then they compare that to, you know, what would be known formulas, and actually can use that to come up with the chemical formula of the compound. So that's kind of why we have 2 ways of solving percent composition problems, because they both have their own uses. In the lab, this is a way you can find out an unknown compound, and in, you know, that compare it to ones that are known. So based on example number 2, what was the unknown compound in example number 1? The unknown compound was H2O, because it has the same percent composition as this formula, and that's always going to be the case. Okay, so let's do another example. So calculate the percent composition of potassium sulfate in the space provided. It's the very bottom of the note sheet if you have that. So go ahead and pause the video, take a moment, calculate this, and when you're ready, resume the video.
Right, now that you've had a chance to do this problem, let's go through the solution. So the first thing that you want to do in looking through this problem is kind of decide what type of percent composition problem you have based on the information provided. Since we are only given a name here, we are not given any information whatsoever as to masses, then this is going to be determining the percent composition from the formula. So then your next step is, what is the formula of potassium sulfate? So you want to go back to all your nomenclature rules and your thinking in your brain. Hopefully you can do this without having to look at notes, and realize that potassium on the periodic table is a symbol of K, and it is a 1+ charge. This is an ionic compound. Sulfate, that is the sulfate ion. You should certainly recognize that as SO4 2-. So putting together the formula here, we are going to be dealing with the potassium taken twice and the SO4 ion taken once. So this is going to be the formula that we are going to be using. All right, so now our next step is to determine the molar mass of this formula. So we will start with our potassium. We will take 2 times the molar mass of the periodic table, 39.1 grams per mole, and we will get 78.2 grams per mole coming from the potassium. And then the sulfur, there's just one of them, so just 1 times that mass off the periodic table. So 32.1 grams per mole for the part coming from the sulfur. And then the oxygen. There are 4 oxygens in this formula. So we're going to have 4 times 16. grams per mole, for a total of 64 grams per mole. And then, of course, to get the actual molar mass, you add everything up for a total of 174.3 grams per mole. Now, I highly recommend that you list and work out your molar mass exactly this way, because when you go and you do your percent composition now, you can just use the pieces of this to calculate the percent composition. So let's go ahead and do that. So we're going to go down here. We're going to say our percent of potassium is going to be, before we do that, let's think about here. This is the case of where we are going to assume that we have 1 mole. One mole of K2SO4. So then we are going to basically know or assume that we have a total of 174.3 grams per mole of the compound. So because of that, then we can use the pieces of our molar mass in calculating the percent composition. But remember, that only works because we are assuming the 1 mole. All right, now let's calculate our percent of each element. So the percent of potassium is going to be the 78.2 grams and of potassium. Make sure that you are including number, unit, and formula in all of your calculations, all over our total mass of our compound. And again, include the formula. The missing formula is by far what I see most common on students who lose points on these problems. It's not that they can't do the math, but they're not listing out the entire process. And remember, we are not teaching you how to do math in this class. We are teaching you a process. Okay. So putting it in here, got it all there. 78.2 grams of our potassium divided by 174.3 grams of the potassium sulfate multiplied by 100 gives us 44.9% of the potassium. 3 sig figs coming from the 78.2 in the numerator of that fraction. All right. So we will work on the sulfate now. Excuse me, the sulfur now. So we're going to do this by element, not by ion. Okay, now for the sulfur, we have 32.1 grams of sulfur, all over 174.3 grams of the full compound potassium sulfate. So we get 18.4% sulfur. And then our percent of the oxygen would be 64.0 grams of the oxygen, all over 174.3 grams of the K2SO4. So we get a total of 36.7% of the oxygen. A final step you always want to do in a percent composition problem is to add up to make sure your percentages do indeed equal 100. You can catch a lot of silly mistakes this way. So if we go ahead and do this, we can see we have 44.9 plus 18.4 plus 36.7, and that does indeed add up to 100%. I would say that you don't necessarily have to show this last step here that I've written in red on the slide, but I certainly think you should do it on every single problem. Obviously, if it doesn't add up to 100, then you've made a mistake somewhere in the problem, and you want to certainly go back and fix it. Well, that I hope clarifies on how to calculate percent composition for the elements in a formula. So, as always, if you have questions, please reach out, and happy learning.